All right, guys, so now we're going to learn about vector addition. First, I just want to review some trigonometry. And so if you have a right triangle here, and I'm just going to make up some numbers, but let's say that's 5, 7, and this angle is 30 degrees. Well, we know this one has to be 60 degrees. But let's just go with the 30-degree angle, I guess. And just remember that first we got to find this hypotenuse, if you will. And that's where we'll just call that x. And since it's a right triangle, you would use the Pythagorean theorem of 5 squared plus 7 squared equals x squared. Of course, you have 25 plus 49 equals x squared. 25 plus 49 is 74. Take the square root of 74. And so our hypotenuse will be 8.6. And this is the Pythagorean theorem. Hopefully I spelled that right. Okay, so to find the hypotenuse, a squared plus b squared equals a c squared. Okay. Hopefully that's a little bit familiar. Okay, so now let's review angles, if you will. And we'll just say A, B, and C there. The cosine of that angle would be A divided by C. The sine of that angle would be B divided by C. And then the tangent of that angle would be B divided by A. And so if you were to want to try to find the actual number of that angle, you could say the inverse cosine of A over C, the inverse sine of B over C, or of course the inverse tangent of B over A. Okay, so in this vector addition, we're going to be using the Pythagorean theorem, and then we're going to use some trigonometry to figure out the angle. Now, the reason we do this in physics is now we're going to be using two directions. Everything we've done so far has been one direction, and now we're going to move in two directions. So let's say east and north. Okay, and if you move east and north, what is your resultant? Okay, what is the result of that motion of moving in two directions? Well, for us, it's very nice. It turns into a triangle, and we can calculate this quantity, this resultant, using Pythagorean theorem and trigonometry. Okay, and then what we're going to learn eventually is if you keep doing this, moving in two directions. So if you move in two directions, and then move in two directions, oops, ignore that part, and keep moving in two directions. Okay, as I totally mess up my drawing here because my app here is doing something goofy. and you add all those up, you'll get a curve. So now instead of moving in a straight line, we'll start moving in a curve. And so we want to be able to calculate, distance, velocity, and the angle. And so we're going to use our trigonometry and Pythagorean theorem to do that. Okay, let's look maybe at a sample problem here, if I can get this to work, perhaps. I think I'll just make that. All right, so apparently I wasn't recording this when I wrote all this out. So here's the question. Object moves 20 miles per hour east, but experiences a push 10 miles per hour south. What is the resultant motion? Or you want to think of that as velocity. So first I draw the picture here, and 20 miles per hour east, 10 miles per hour south. And I want to draw that to scale, usually using graph paper. For example, you would just say one block is 10 miles per hour. Now your answer has two parts, two things, magnitude and direction. Magnitude, think of it as the length of the line. Direction, what is our angle? So if you look back at our picture, the red dashed line is our resultant. Okay, you always add vectors from beginning to the end. Okay, start point to the end point. So we're looking for the length of this line and its angle. What's its direction? Vectors always have a direction. So to find the length, I would just use Pythagoras. X squared equals 20 squared plus 10 squared. X squared equals 400 plus 100. So x squared equals 500. X equals the square root of 500. So x is 22.4 miles per hour. Find the angle. There's several ways. I just did the inverse cosine. 20 over 22.4, 20 miles per hour. 22.4 is the hypotenuse. So the inverse cosine of 0.833 is 33.6 degrees. So my resultant, 22.4 miles per hour at 33.6 degrees southeast. So if you had two components to your velocity, one east and one south, your object would actually follow this red line. And then if it continuously did this, it would actually turn into a curve shape, which we'll talk about a little later. But right now we just want to kind of practice our angles and finding the resultant. So another kind of question I could ask you is to find the components of a particular vector. In this case, I would give you the resultant. And let's just say this is 33 meters per second squared. And I want to know what are the components. So in this case, you're looking for that line and that line. Assume I drew those straight. Okay. And then in this problem, I'd have to give you the angle, and I'm just going to make up an angle that's 40 degrees. Okay, find the components of that resultant or that vector. So, which just means just find the length. So I need to know what x is, and I just need to know what y is, I guess. Just making up variables here. So to find x, I would say the cosine of 40 degrees equals x over 33. Okay, so adjacent over hypotenuse. Cosine of 40, 0.766 equals x over 33. So multiply by 33. You get 25.3. That would be meters per second squared. To find the y component, this time I would use the sine of 40 degrees equals y over 33. So 0.643 equals y over 33. In this case, I'm going to multiply by 33 times 0.643, and we get 21.2. So my components would be in the x direction 25.3 meters per second squared, and in the y direction 21.2 meters per second squared. So find the resultant, find the components. Those are the two things we want to work on in this week.